this episode, we shift into Domain 2A by building a clear mental picture of an AI data pipeline, which is the path data takes from being collected in the real world to being used in training, testing, and operation. Beginners often hear the word pipeline and imagine something technical and mysterious, but the core idea is very human. Information is gathered, transformed into a form the model can learn from, stored somewhere, and then accessed by people and systems that need it. If any part of that journey is messy, unclear, or poorly controlled, the AI system can inherit errors, bias, and privacy risk in a way that is hard to unwind later. Understanding the pipeline also helps you understand where assurance work lives, because assurance is about checking that the right controls exist at each stage, not just checking the final model output. As we walk through collection, labeling, storage, and access, the goal is to make each step feel concrete and intuitive, like you could describe it to a friend without using technical jargon. Once you can do that, you can start asking the right questions about data quality, governance, and risk with confidence. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Collection is the first step, and it is where many long-term problems begin because collection choices shape everything that follows. Collection means deciding what data to gather, from whom, in what context, and for what purpose. Data can be collected directly from people, like form entries, support chats, or feedback surveys, or it can be collected from systems, like logs, transaction records, sensor readings, or system performance metrics. A key beginner idea is that collection is never neutral, because what gets measured and recorded depends on what the organization believes matters. If a school collects detailed engagement data but never collects context about accessibility barriers, the dataset may quietly treat those barriers as student behavior rather than environmental constraints. If a company collects security alerts but changes logging settings over time, the dataset may reflect tooling changes more than real threat changes. Collection also includes how consent, notice, and expectations are handled, because people may agree to one kind of use but not to another. A pipeline that begins with unclear collection is like building a house on uncertain ground. The problems may not show up immediately, but they will show up later. Another practical aspect of collection is representativeness, which means the dataset should reflect the real population and conditions the model will face. If the collected data mostly comes from one channel, one region, or one type of user, the model may perform well for that slice and poorly for others. Sometimes representativeness problems happen because certain groups interact with the system less, or because the system records their interactions differently. For example, if one group is more likely to use phone support while another uses chat, and only chat is collected, the dataset will miss important variation. Collection can also be biased by incentives, like when employees know metrics are being tracked and change behavior to look good rather than to be effective. Beginners can evaluate collection by asking simple questions about coverage, time period, and context, such as whether the data includes weekends, seasonal cycles, and unusual events. The collection phase is where you decide what reality the model will learn, so the more honest and complete that reality is, the safer and more reliable the system can be. After collection, the data usually needs cleaning and preparation, even before labeling, because raw data is often messy and inconsistent. Cleaning can include removing duplicates, fixing obvious errors, standardizing formats, and handling missing values. It can also include deciding how to treat outliers, like extremely rare values or unusual events that might be important signals or might be noise. A beginner mistake is to assume cleaning is purely technical, but cleaning often includes judgment calls that can affect fairness and privacy. For example, removing rare cases might improve overall accuracy, but harm the very people who show up rarely in the dataset. Filling missing values might introduce assumptions that affect some groups more than others. Combining datasets can create privacy risk by enabling linkage, even if each dataset seems safe alone. These preparation steps are part of the pipeline because they change the information the model learns from. The better the organization documents these steps, the easier it is to audit whether the pipeline is producing trustworthy training material. Labeling is the stage where many people first feel the pipeline becoming AI-specific, because labeling is what turns data into examples the model can learn from. A label is the answer you want the model to learn, like spam or not spam, urgent or not urgent, suspicious or not suspicious, or satisfied or dissatisfied. Labels can be created by humans, derived from system outcomes, or generated through a combination of rules and review. In everyday terms, labeling is like attaching sticky notes to examples so the model can study them. The quality of those sticky notes determines the quality of the learning. If labels are inconsistent, subjective, or influenced by unfair prior decisions, the model will learn those patterns and repeat them. Labeling is also where bias can enter through human judgment, because different labelers may interpret categories differently, and their interpretations may be influenced by experience, training, and social assumptions. Understanding labeling helps beginners see why fairness is not only a model issue, it is often a label issue. Labeling also has a supply chain, meaning labels do not appear magically. They are produced through a process that can include training labelers, providing guidelines, resolving disagreements, and auditing samples for quality. If labelers are rushed, labels become sloppy. If guidelines are unclear, labels become inconsistent. If disagreements are never resolved, labels become noisy, and the model learns contradictory lessons. Some pipelines use external labeling vendors, which adds complexity because the organization must ensure the vendor understands definitions, handles data securely, and does not introduce new bias. Labeling can also include sensitive exposure risk, because labelers may see personal information in text, images, or audio that should not be widely shared. A responsible pipeline defines what labelers are allowed to see, how access is controlled, and how labeling work is monitored for quality. For beginners, a useful way to think about labeling is that it is both a quality process and a governance process, because it shapes truth for the model and therefore shapes impact for people. Storage is the stage where data becomes an asset that must be protected, controlled, and managed over time. Storage is not just a folder. It includes where data is kept, how it is organized, how versions are tracked, and how long it is retained. In AI pipelines, storage often includes multiple copies, such as raw collected data, clean data, labeled data, training splits, and evaluation datasets. Each copy can create risk if it contains personal or sensitive information, because more copies mean more opportunities for leakage and misuse. Storage also intersects with integrity, meaning you must be confident the dataset has not been tampered with or accidentally altered. Without integrity controls, you can retrain a model on corrupted or outdated data without noticing, which can create drift or unfairness. A beginner-friendly view of storage is to treat it like a library. You need clear organization, controlled access, rules about what gets archived, and a way to know which edition of a dataset you are using. If you cannot tell which dataset version trained the model, accountability becomes difficult. Retention and deletion are part of storage, and they are often where privacy promises either hold up or fall apart. If a privacy program says data is retained for a certain period, the pipeline must enforce that across all copies, including backups and derived datasets. If someone requests deletion and the organization promises to honor it, the pipeline must have a method for locating and removing that person's data where appropriate, or at least preventing future use. AI makes this complicated because the model may have learned from the data, and removing influence may not be immediate. Even if the organization cannot fully undo past influence, it should have honest processes for preventing new inclusion and for limiting storage of personal content going forward. Storage also includes the handling of prompt logs and outputs for systems that interact with users, because those logs can become a growing dataset of personal information. A responsible pipeline treats prompt and output storage as a governed dataset, not as casual debugging text that lives forever. Access is the final stage we focus on today, and it may be the most important from an assurance perspective because access determines who can see, change, or use the data. Access includes permissions for engineers, data scientists, analysts, labelers, vendors, and sometimes business users. It also includes automated access by systems, like training jobs and evaluation jobs, which need credentials and should be limited to what they truly require. A beginner-friendly way to think about access is the principle of least privilege, meaning people and systems should have only the access necessary for their role and no more. If everyone can access raw personal data, risk is high even if the organization trusts its employees. Access also includes the ability to export data, because uncontrolled export creates leakage pathways. In AI contexts, access can be risky because people may want to pull data for experiments, and experiments can create uncontrolled copies. A strong pipeline makes it easy to do the right thing and hard to do the risky thing. Access control also includes accountability and monitoring, because controlling access is not only about setting permissions once. Organizations need to know who accessed datasets, when they accessed them, and what actions they took. Monitoring access helps detect misuse, such as someone pulling large amounts of data unexpectedly or a vendor account being used outside normal patterns. It also helps in incident response, because if a dataset is exposed, you need to know what happened and what data was involved. Access governance becomes especially important when datasets contain sensitive content, like medical details, student records, biometrics, or internal confidential documents. Beginners sometimes assume access is a pure security topic, but it is also an ethics and privacy topic because access determines who is exposed to personal information. A pipeline that protects access protects people. It also protects the organization's ability to defend its decisions, because controlled access supports traceability and confidence in data integrity. Now connect collection, labeling, storage, and access into one coherent story, because the pipeline is only as strong as its weakest stage. If collection is broad and unclear, labeling will inherit messy and biased signals. If labeling is inconsistent, the model will learn inconsistently even if storage is perfect. If storage has uncontrolled copies, privacy risk multiplies and retention promises become unrealistic. If access is too open, sensitive data exposure becomes a matter of time. This is why AI assurance often begins by asking for an end-to-end data flow story, including where data originates, how it is transformed, what versions exist, and who can touch it. In everyday terms, you are tracing the path of ingredients from farm to kitchen to plate, checking that each step is safe and well managed. When you can tell that story clearly, you can identify where controls must exist. When the story is vague, the organization is likely relying on assumptions rather than governance. A practical way to solidify your understanding is to imagine a simple text-based AI assistant used by a school to help staff answer common questions from students. Collection might include past support emails and chat messages, which could contain personal stories and sensitive details. Labeling might involve marking which responses were correct or which issue category each message belongs to, which can be subjective and inconsistent without clear guidelines. Storage might include raw message archives, clean datasets, and training sets, each of which could contain student information that must be protected and retained only as long as necessary. Access might include staff, vendors, and developers, and without careful controls, too many people could see student data. Even in this simple example, you can see how pipeline stages create ethical and privacy stakes. The assistant might seem harmless, but the pipeline can expose personal data, encode unfair assumptions, and create outputs that leak context if not governed. This kind of example helps beginners see why pipeline understanding matters to responsible oversight. To close, understanding AI data pipelines in terms of collection, labeling, storage, and access gives you a powerful, practical framework for Domain 2A. Collection determines what reality is captured and whether it aligns with purpose and expectations. Labeling determines what truth the model learns and whether that truth is consistent and fair. Storage determines how data is protected, versioned, retained, and traced over time so accountability is possible. Access determines who can see and use the data and whether exposure risk is controlled through least privilege and monitoring. When you can describe these stages clearly, you can ask sharper questions, spot hidden risk pathways, and evaluate whether an organization's AI work is built on disciplined foundations. This is the kind of understanding that makes later discussions about traceability, bias, privacy, and drift feel logical rather than overwhelming, because you can always return to the pipeline and ask what went in, what changed, what was stored, and who could touch it.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.